Hello, welcome to the next section, Pain Points of Convolutional Neural Networks. In this section, we will look at some of the pain points associated with working on a convolutional neural network for image recognition and how they can be overcome. Let's begin this section with the first pain point, that is, importing MNIST images. One of the most common datasets used for image classification is the MNIST dataset, which is composed of thousands of samples of handwritten digits. The Modified National Institute of Standards and Technology, MNIST, is, according to Jan LeCun, Karina Cortez and Christopher J.C. Burgess, useful for many reasons. There are several methods to import the MNIST images into your Jupyter notebook. We will cover these two methods in this section. 1. Directly through the TensorFlow library. 2. Manually through the MNIST website. The only requirement needed is to install TensorFlow. It will likely not come pre-installed with the Anaconda 3 packages. Therefore, a simple pip install will either confirm the availability of TensorFlow or install it if not correctly available. TensorFlow can be easily installed in the terminal using pip install command TensorFlow. Once this is installed, let's move to your Jupyter notebook. The TensorFlow library has a conveniently built-in set of examples that can be used directly. One of those example datasets is MNIST. Now we will walk through the steps to access those images. First, import TensorFlow into the library with an alias of TF. Then we confirm the version of TensorFlow. Then we extract the images to our local folder of MNIST/. The extraction process is visible in the output of the notebook, as seen here on the screen. You can ignore the warnings. Here you can see the extracted files. Opening the MNIST folder, you get to see the 4 extracted files. They have been downloaded to the MNIST// subfolder. In addition, the 4 files can be viewed in our notebook using this code. The 4 files are the testing and training images, along with the accompanying testing and training labels identifying each image in the testing and training datasets. Additionally, the one_hot equals true feature is explicitly defined. This indicates that one-hot encoding is active with the labels, which assists with feature selection within modeling, as each column value will be either 0 or 1. Retrieve a final count of the training and testing datasets that will be used to evaluate the accuracy of the image classification using this code. Here a subclass of the library is also imported that stores the handwritten images of MNIST to the specified local folder. The folder containing all of the images should be approximately 12 megabytes in size for 55,000 training images and 10,000 testing images. The 10,000 images will be used to test the accuracy of our model that will be trained on the 55,000 images. Occasionally, there may be errors or warnings when trying to access the MNIST datasets directly through TensorFlow. As was seen earlier in the video, we received warning when importing MNIST. The dataset may become deprecated in a future release of TensorFlow and therefore no longer be directly accessible. Sometimes we may just encounter a typical HTTP 403 error when extracting the MNIST images through TensorFlow. This may be due to the website being temporarily unavailable. Have no fear in either case, there is a manual approach to download the 4.gz files using this link. The files are located on the website. Download the files and save them to an accessible local folder, similar to what was done with the files that came directly from TensorFlow.